Histograms. To find out what they are, let's ignore the word histograms and just plot a bar chart. So if we take this table, we have some frequencies for a particular set of figures, groups that, notice, are not of equal width. So let's see what it's going to look like if we try drawing this. We'll put some axes in, and let's put some scale on the bottom, which will go 0, 1, 2, 3, 4, 5, 6, 7, 8, corresponding to the figures we see in this table. From 0 to 1 we have a frequency of 2, a maximum frequency to consider of 20, notice there, and it's going to be from 0 to 1 as 5, 15. It's going to look something like this. From 1 to 4 it's going to go all the way up to 15, and my hand a bit shaky on that, gets the figure there. It goes all the way up to 20 from 4 to 6, and it's up to 4, slightly below the 5. That's a good approximation. So that's roughly what my bar chart would look like. But what I want you to consider is that as you look at that, there looks to be a lot of data in this area here. An awful lot of data. Actually, how much data is there? There's 2 items there, 15 here, 20 there, 4 there, and 3 there. In fact, to see it more accurately, let's have a little look at one I drew earlier, which is far neater. Okay, here we have, this represents 2 items, this represents 15, this represents 20, 4 and 3, and of course they're all coming from this column here. And what I want you to consider is, does it look realistic? Because I have a problem with these 2. This one, it's quite a big area, represents 15. This one is bigger, and yet the area is smaller. If you don't see that, it's perhaps I could show it using a little area cover here. That area represents 15. It's actually bigger than this area. There's an awful lot left over to fill up the space, but it's supposed to represent 20. So that's the problem. That is the problem with a bar chart. The areas clearly are not proportional to the things they represent. And that's what's wrong with a bar chart, which isn't the problem with a histogram. Because a histogram, the area of the bar is actually proportional to the number of things it's representing. So that's a condition of a histogram. So let's have a look at what a histogram would look like, and let's see if it actually does that. Okay, here we have a histogram where, again, as before, this represents 2, 4, 3, not a problem. This represents 15 and this represents 20. That looks quite reasonable. In fact, it's quite easy to see. Look, that's 4. You'd fit a 4 in there, a 4 in there. That would be up to 12, 16, and there's your final 4. That looks pretty good. I'm quite impressed with the way that does seem to show that area of bar is indeed proportional to the frequency. And so that is clearly a histogram. So our only problem is, how do we draw them? Well, for that we need to bring in this table. And if we put the table up there, you'll see the difference that's made. Same as before, exactly the same data we had before, but this time we look at a group width. From 0 to 1, the group width is 1. From 1 to 4, that's 1 to 2, 2 to 3, 3 to 4, the group width is 3. From 4 to 6, the group width is 4 to 5, 5 to 6 is 2. 6 to 7 is still 1, and 7 to 8 is still 1. And to get the frequency density, you take the frequency and you divide it by the group width. And as you can see, 2 divided by 1 remains 2, but 15 divided by 3 turns that into 5, and 20 divided by 2 makes that into a 10. And so the figures that are plotted instead are 5 at that point, and here of course 10 at this point. And this column is no longer the frequency, but the frequency density. So this simple calculation enables you to get a bar chart in which the area of the bar does proportionally represent the frequencies. And that is called a histogram.